All right, we're going to do a substitution reaction on 1-butanol to make 1-bromobutane. So to do this, we're going to start off. We've got our 1-butanol, so 1.7 milliliters of that. We'll add that to our flask. And we might as well get our boiling chips in now. So put a boiling chip in, maybe 2. Next, we're going to add our HBr acid in. And we're just going to use the pipette measurement right up to the top of the bulb, right before you get to the bulb is 1 milliliter. And we need to add 3.5 milliliters to this. And this is concentrated hydrobromic acid, so we're being careful with this material. All right, now after you've added that, we're going to actually set up a reflux because this reaction is going to take 45 minutes to complete. Now, reflux on a microscale kit, we're just going to use air condensers, but the length of the air condenser is not quite sufficient to make sure that none of this gets out. So we've added a second air condenser onto the top. And we just use one of those connectors to add it. So we'll now add that on here. And now we're ready to start the reflux. And we'll come back when the reflux is started. All right, so now the solution has started to reflux. After it starts boiling, we're going to let this reaction go for 45 minutes. And we want to make sure that it doesn't get too violent, and we're going to watch and see where it's condensing. Right now it's down here, but we've got plenty of condenser. It probably won't come out. And just for reference, that's what we've got the heating well set on, about 3.5. And we may need to adjust that coming up here, but we're just going to make sure that this reflux stays about like this, maybe a little bit more vigorous, but this looks really good for now. All right, it's been about 20 minutes, and you can see here that there's a little layer forming on the top, and that's product forming. And you can see just how the condenser is working there. And if we look up here, you'll see why we have 2 condensers on top. That's because the liquid is already coming up to this second condenser. And that's largely because we've got quite a bit of water down in here, and so the reflux is going to be a pretty high temperature. So we need more condensing capability, so that's why we have to add the second one on here. So we'll come back after the reflux is completed, but again, it's just nice to see that we've got a little product layer forming there. Okay, so it's been 45 minutes. Now, what we're going to do next is we've got a weighed Erlenmeyer receiving flask. We've got our distillation set up here, already prepared. We're going to take off this top column and we're going to put this in its place. So we'll just do that quickly, and it's hot. I'll do that, and I've got a masonite square here so I don't have to hold the receiving flask there. Now the next thing that we're going to want to do is we're going to wrap some of this in either glass wool or perhaps some tin foil to help insulate it a little bit. So that will just help the material actually make it up and over into the flask. Now, we want to be patient with this distillation. It can take up to half an hour. So I'll show you what it looks like after I've got all the insulation material on there, and we'll come back.
Good.
All right, so we've got the insulation material on there. I've put a little glass wool around it, and then I've also put a little tin foil or aluminum foil around there, and I've left a little gap so I can still kind of see what's happening inside the flask, because remember, we don't actually want to distill this to dryness. And we'll look up here, we've got our distillation head set up, and I've got my receiving flask right here. And we'll just kind of keep an eye on this and try to isolate our product. Okay, so if you've noticed, the second layer has now disappeared. And so we're going to let this distillation go for a few more minutes, and then we'll stop it. And you'll see we've got quite a bit of product over here. And then we'll continue on with the next step after a couple minutes here. All right, so we've transferred our product, our distillate, into the centrifuge tube, and we're going to add 0.3 milliliters of concentrated sulfuric acid to it. We'll mix that around for 30 seconds or so. So we could actually use a pipette to do that if you want. I would use a glass pipette.
Okay.
All right, now we're going to want to keep the organic layer. Now, it's very possible to throw away the wrong layer. So, what we're going to do is keep both layers just until we have our product. So, first thing we want to do is pipette off the bottom layer. Now, usually, when you have concentrated sulfuric acid, that's pretty dense, and so usually that's on the bottom. So we're going to do that. Let me put this. But we're going to make sure and keep both of these. So we need something to put this in. All right, now we've got those layers separated. We'll get to move on to the next step. Which is adding a little bit of sodium bicarbonate solution to help neutralize any residual acid that we have. Now, if we add the sodium bicarbonate solution to this, and we just see a lot of bubbling, and we don't see 2 layers at the end, then you know you've got the wrong layer in the flask, right? Because the bicarbonate solution is an aqueous solution. So if it's all 1 layer, then your product is in the other flask that hopefully you saved just in case. All right, now, again, it's easy to get the wrong layer here. So we're gonna separate these and come right back. All right, so we just checked the densities just to make sure. Now, before the sulfuric acid, that's a pretty dense solution. It's like 1.8 grams per milliliter. And so that was on the bottom. But if we've done our homework here, we'll know that the density of the product that we made, 1-bromobutane, is about 1.2. Now, that's less than the 1.8, so that's why before it was on the top, right? It was up here when we had the sulfuric acid down. But now we don't have a very dense solution. We've got water, and the water layer is going to be now on top, and our product layer is going to be down here. So it's really important to pay attention to this. And again, don't throw away any of the layers until you have your product for sure. And I would say you have your product for sure when you have the IR of it recorded. So I'm going to go ahead and pipette off this lower layer, because when you're using a centrifuge tube like this, you always pipette the lower layer off, because you can get down and get that one out without disturbing the top one. So get that. And we'll try not to get any of the water with it, which again, in this case, is on top. Sometimes it gives you a little bit of trouble by floating around a little bit there. So we'll have to let that settle down again. We'll just get that, and I'm just going to try to leave all the water behind. So I've got this, that should be separated now, and our product should be in this container. Now we're going to dry this with sodium sulfate or anhydrous, because we're going to have a little bit of water with that. And then we'll do all of the things that we would need to isolate our product. So that's next. All right, now, when I'm transferring something that's been dried, sometimes it's nice just to get a new pipette, just so that I make sure that there's no water coming over with it. So we've got our product here. We're just gonna pipette this out into a flask that we've weighed, and I want to make sure and not get any of the drying agent in there. So one of the things that we can do, you can see there's some of it right there, so I'll just let that come out of the pipette at the bottom. Then I'm going to put it over into our weighed vial. And I have definitely lost a little bit of the product over here, because it's hard to get it all away from a lot of that drying agent. but we'll try to get as much of that as we can so we get a highest yield. All right, so then we're gonna go and weigh this and measure the IR, and we'll be done.